three forces acting on a boat. 460 newtons at 25 degrees south of west, 140 newtons at 35 degrees north of west, and then 99 newtons at 5 degrees north of east. And what we want to know is what is the net force. So force is a vector, so I need magnitude and I need direction, okay? So the first thing I'm going to do is set up a little table for my x and my y components. And remember, x is east, positive, west, negative. For y, north, I'm going to call that positive, and south, negative, okay? So I need to break these, all three of these down into their perpendicular components, because they need to be perpendicular, which is a right angle, for us to do any right triangle geometry or trigonometry with them, okay? All right, so I'll just start with the first one. 460 newtons at 25 degrees south of west. I'm just going to draw a picture here. That would look something like this. Here's west, and 25 degrees would be something like that, okay? So I need to find the x part, which is adjacent, so cosine, and I need to find the y part, which is opposite, okay? All right, so we know that the cosine of 25 degrees is going to be this adjacent over hypotenuse. So you just multiply. So 25 cosine times 460, and I get 417. Looks like I have two sig figs, so I'm going to call that 420. And that's west, so that is negative 420. All right? So here I have sine, so sine 25 equals south over 460. So 25 sine times 460, and I get 194. Again, two sig figs, so I'm just going to round that down to 190, and that's south, so that's also negative. So boom, first one done. I'm going to go ahead and erase this. All right, the second one is north of west. So here we are still west, and it's 35 degrees. Okay, so again, it looks like, oops, let me stick with my color coordinated. Again, it looks like the west part is going to be negative, and then we got a positive this time. Okay, all right, so this is adjacent. That's my x part. So cosine of 35 equals x divided by 140. That's what that looks like. And remember, when I punch it in the calculator, I just hit 35 cosine, and I go ahead and multiply by 140 without rounding, and then I round later. I get 114, and it's two sig figs, so I'm going to round that down to 110. So that's west still, so that's negative 110. And then for the y, that's opposite. So sine of 35 equals north this time over 140. 35 sine times 140, 80. It's two sig figs. This time that's positive, so positive 80. Hey, almost there. Last one, 99 newtons, 5 degrees north of east. Oops. So this time, I'm going towards the east. 5 degrees is tiny. So here's 99 newtons. 5 degrees. Yeah, I know that's two sig figs. Whoops. All right, so there's my little northward component. Here's my rather substantial eastward component. Okay. All right, so I'm not going to write it all out this time. So cosine of 5 times 99 is going to equal our x or eastward component. And it should be really close to 99. So I get 98.6, 2 sig figs, so that rounds to 99. Don't worry about the rounding, it's fine. So that's 99, and that is positive because it's that way. Okay? And then the northward component is sine of 5 degrees times 99. And that's going to be tiny. And I get 8.6, 2 sig figs. Yeah, so 8.6. And that's up, so that's positive as well. All right. So I've broken all 3 of these down into perpendicular components. I'm going to add them all up, and then I'm going to have the perpendicular components of our overall resultant net force. All right? So I got 420 minus 110 plus 99. I get 431. I got to round to the tens place. So 430. Negative, should say. 430. So that 430, that negative on here, that means that is negative 430 or 430 west. Okay? So just for picture's sake, my x component is 430. Let's get rid of this. All right, our y's, we got negative 190 plus 80 plus 8.6. I get negative 101.4. Again, it looks like our tens digits, so let's just say negative 100, which in y, north-south, that means that is south. Now notice when I go down here to draw this on our resultant, I'm not going to put it here, that might confuse people. Since I'm actually doing some math here, I'm going to go ahead and add it tip to tail. So we got 100 there. So our overall resultant is going to be this. Ooh, I love that sound. This magnitude at this angle. By the way, that angle is south of west, so I'm going to go ahead for my answer, go ahead and put south of west. Okay, so go ahead and use Pythagorean theorem here just to get the magnitude. 100 squared plus 430 squared equals, oops, I just messed it up. 100 squared plus 430 squared equals, square root it. 440 is what it looks like. So our unit was newtons because this is a force, so 440 newtons. So there's half my answer. Okay, now I need to know what this angle is. I'm going to go ahead and do sine. So if I want to find the sine of theta, that is going to equal the opposite divided by the hypotenuse. So 100 divided by 440. I get some decimal number. I'm not going to round it or anything. I'm just going to go ahead and take the inverse sine, and I get 13.13 blah, blah, blah. I'm just going to say 13 degrees. So 13 degrees south of west. Now, this next part, what I'm going to do here, this is not necessary, but I'm going to go ahead and kind of guesstimate this graphically just to see if that makes sense. So, here's our boat. It looks like a horrible boat. But let's take a look at our first vector. 460 at 25 degrees south of west. I'm going to draw that in pink. And I'm just going to estimate here. But 460, 25 degrees south of west. I'm going to put that out about this far. Next one, 140, and now I'm going to come out here, because this is how I would solve it graphically if I was going to do that. 140 newtons, 35 degrees north of west, and it's about about a third of that. And then I'm out here, because I'm adding this tip to tail. This is how I would be doing it if I was solving it graphically. And then 99 newtons, 5 degrees north of east. So 5 degrees north of east is pretty much in this direction, 99 newtons. Okay. Then I'm going to use this black. I'll use this black one. So if I was doing this graphically, that would be my vector. So 13 degrees south of west. So yeah, south of west, it's a very shallow angle. 440 newtons. Yeah, it's pretty close to that size. That one's 460. So that's how I would solve it graphically if I had a protractor and I was measuring angles and a ruler and all that kind of stuff. But I just kind of did that kind of freehand just to see if that makes sense. You don't have to do that. But. All right, so there we go. So that's 3 vectors, none of them on the axis. So you had to break them all down into components. If you can do this, you can do any of them. Okay? Any of them. All right, cool.